basically asks you for the moment of rotation. They're basically asking about the tendency of an object to rotate. For us to find the moment of rotation, or just the moment, we need two different things. The distance from the point of rotation to the line of action, and the force acting upon the line of action. When they say the line of action, it's basically the line from the place where the force is acting upon. So the official definition of moment is d dot f perpendicular, or d perpendicular dot f. Now we need to make sure that the distance or the force is always perpendicular, and sometimes the problems we are given, in one of them is not perpendicular. In cases like that, we first just draw it out. For problems like this, for example, where we have d here and the original f here, this is not perpendicular. So what we have to do for this one is find the y component and then find the theta, or the angle between the actual force and the y component of the force. And then, for this one, our equation then becomes d dot f cosine of theta. For problems where they ask you to find the direction of the moment, we have to use the right hand rule, where we take our four fingers of the right hand and point them towards the distance, and then we curl it towards the direction of the force. If your thumb is pointing outward, if your thumb is pointing towards you, then that means that your moment is positive. If your thumb is pointing away from you, then that means that your force is negative. Now, to make the concepts even clearer, we're going to go through a worked example. Now we're going to go through a worked solution where if we are given this in a problem and we're asked to find the moments about O, the first thing we do is write down the base equation, which is moments equals to the sum of all forces times the distance. So going out from O, the first thing that we encounter is this 50 Newton force going downwards. So since this is going down, this is going to be minus 50 times the distance, which is 2. Since they are perpendicular to each other, we don't have to worry about any angles or anything else. The next thing that we do, we have to add them since it's a sum of all forces. The next thing that we encounter is this 200 Newton force. Even though it's at an angle because it's working on the rod downwards, pointing downwards, we have to take into consideration this theta and 3 meters. So to basically find the perpendicular distance, we have to use SOHCAHTOA for the triangle. So since this is opposite the theta, we have to do sine in this case. So for this one, it is 20 newtons with the dot product of 3 meters and sine 30 to find the y component of the distance. So then this becomes minus 100 plus 30. So our final answer is then minus 70 Newton meter, where Newton is the unit, newtons for force, meters for distance. And that is how we solve 2D moments.